So in the last session, I started the chapter electricity, and I explained you potential and potential difference. Now let us revise that in few minutes, and then we'll start today's topic of resistance. So first, for revision, let us read the numerical. How much work is done in moving charge of 5 coulomb? So I've got a charge of 5 coulomb, and I'm moving from 110 volt to 160 volt. So there are 2 points. This is 110 volt. I am moving from 110 volt to 160 volts. So my potential difference is 160 minus 110, which is 50 volt. Now what is the formula we learned? That work done per unit charge is the potential difference between the 2 points. So now in this sum I have to calculate the work done. So work done would be Q into PD. Now Q is 5, PD is 50, so work done is 250 joules. So this formula, which I explained to you last time, we have used it now. Next, what is now PD developed? So now is asking V, PD developed across battery. Now work done is 200, and we are transferring is 20. So work done upon Q is PD. Now work done is 200 and coulomb is 20. So 200 upon 20 will give 10 volt. So the potential difference was 10 volt. Is it all right? Then about direction of electric current, I explained to you that always we will be showing the direction from positive. Bigger line of the battery or cell means positive. The current flows from positive, passes through the circuit, and then it comes back to negative. The current is from positive to negative in external part of the circuit. This is a conventional direction, though electrons might be moving from negative to positive. Okay? So it's all circuit diagrams will be showing the current direction from positive to negative. Then this is called a electric circuit, which is a closed path for the current to flow. And when we are showing it by symbols, this is called a circuit diagram. Rheostat means variable resistance, which is shown by in this manner. This is a variable resistance. I can change the resistance value by moving a slider. Okay. Then now pay attention. What is galvanometer and ammeter? Ammeter measures the current, whereas galvanometer detects the current. Now whether the current is flowing or not. So because now suppose in a circuit these 2 points are at same potential, so the current will not flow. So this galvanometer will show 0. But in case this is at a higher potential, the current will flow in this direction, so galvanometer will move. And in case this is at a higher potential, the current will flow in this direction, and now galvanometer will move in the opposite direction. So galvanometer is always central 0. In the middle there is a 0. Here there is some 10 ampere. Here it might be some 1 ampere. Here it might be 1 ampere. Both the side may be 1 ampere. Central is 0. So this is a galvanometer. We will be using it in experiments to detect the current. Okay, and ammeter will be using it to measure the current. Okay, so we will proceed further to our today's topic, Ohm's law. Now, as I explained to you last time, in case there is a level difference, then the water, if there is a level difference between 2 points. This is one tank, this is another tank. This tank is having water at a higher level, this is having up to lower level. So if these 2 tanks are connected, water will flow from higher tank to water flow from tank having higher level to tank at lower level. Now the rate of flow depends upon this level difference. Similarly, I told you current flows from one point of the conductor to other point at one point of the circuit to other point from higher potential to lower potential. If this is 10 volt, this is 2 volt, current will flow from 10 volt to 2 volt. Okay. Now, how much current will flow? So that will depend upon PD. So current flowing will depend upon potential difference. More is the potential difference, more current will flow. Obvious. Now, so we will say potential difference is proportional to current flowing is proportional to potential difference that is applied. But there is one condition. Temperature should not change, because if temperature changes, then my electrons in the conductor will get higher energy, so it will, this linear formula will not become true, it will change. So we should remember Ohm's law says current flowing in a conductor means a conductor is having some resistances. So I have connected a battery. So current flowing through this resistance depend upon whether I apply 2 volt, 4 volt, 6 volt, 8 volt, 10 volt. Conductor is same. More the potential difference I apply, more would be the current. Okay. So potential difference decides the amount of current that will flow, provided temperature remain constant. So if V is proportional to I, so I can say V is equal to some constant R into I. So I can say V upon I is R. This R is called resistance of that conductor. R is called resistance of that conductor, and its unit would be, so unit of R would be V upon I. Now V is measured in volt, so would be volt, so it will be volt ampere raised to minus 1, because I is in the denominator. So what is the unit of R resistance? Volt V into A raised to minus 1. But so again, instead of calling it in such a big form, so this is called ohm. So V A raised to minus 1 is called ohm, and it is abbreviatedly written in this manner. This is called, so unit of resistance is ohm. It is nothing but V multiplied by A raised to minus 1. So how I can define that? I can say that 1 ohm is resistance of a conductor when we are applying a potential difference 1 volt across its end and a current of 1 ampere flows, because R is equal to V upon I, isn't it? R is equal to V upon I. So if I apply a potential difference 1 volt and current flowing in that conductor is 1 ampere, then I say resistance is 1 ohm. Is it all right? So this is how Ohm's law defines the SI unit of resistance. So there is a simple numerical I am given. I am applying 12 volt and resistance is 4. So what is the current? V is equal to IR. You learn this only one formula. V is equal to IR. So V is equal to IR. Now I have given V, I have given R. So I would be V upon R. So V upon R would be, will give me 3 ampere. Okay. Next sum. An electric appliance is drawing a current of 3 ampere. So current is 3 ampere. I have connected to 240 volt. So it says what current will it draw? If in case I would have connected 110 volt, it says what would be the current at that time. Because resistance of my appliance is not going to change. Resistance is not going to change. We are making that assumption that temperature is not changing. So R is V upon I. So in the first case it is 240 upon 3. In the second case it is 110 upon X. So you cross multiply and get the value of X. Simple algebra. So you will get 1.37 ampere. Is this all right? Now let us do an experiment to verify this Ohm's law. So this circuit diagram I showed you last time also. This is the battery, this is the ammeter which will measure the current in the conductor. So I am doing an experiment on this conductor. So I will have to, from these 2 points, ends of the conductor, I am measuring the voltage, how much voltage I am giving. How I am changing this voltage? I am not changing the amount of battery, but I have got a rheostat. So in rheostat, if I change the resistance, the PD and current will change. In case the resistance is less, more current will flow. Resistance is more, less current will flow. Now let us do the experiment in this manner. I switch it on. My rheostat was in some position, and I have taken a reading of V and I. Now to change the value of resistance, to move in this direction. So as I am moving this slider in this direction, my resistance will change. So if the resistance changes, I will again take reading of V and I. So take few readings of V and I. If you want, we can move it in this direction also, rheostat. So take various values of V and I, make a table. You will observe that when V becomes more, I becomes more. If I plot a graph, you will get a graph of this. After making the table of potential difference and current, we will plot a graph as shown in this slide. You can see it is a straight line indicating that V and I are linearly dependent, or V upon I is equal to constant. Okay, so V upon I is constant. V upon I is constant, and that constant is called R, which is called resistance of the conductor. So this is verification of Ohm's law. Now if I got a conductor, then what are the parameters on which its resistance will depend? So first parameter is length of the conductor. See, this is very obvious. Like, first let us try to understand the meaning of resistance. Resistance means obstacles that current has to overcome when passing through the conductor. So if this is the conductor, current is flowing. So when current means, as I told you, electrons are flowing in the opposite direction. So when electrons are flowing in the opposite direction, it has to pass through gaps between various atoms. So if this is one atom, this is another atom, so this is another atom, so it is passing through the gaps. And when it is passing through the gaps, the nucleus, which is positive charge, may attract the electron towards itself. So the direction of the electron will change, or if the temperature rises, as I told you, the atoms will vibrate with a larger frequency, with larger amplitude, so electron may collide and its direction will get changed. So these are the various obstacles that electron has to overcome. So in case, suppose you are going from place A to place B, it is 1 meter apart, you will have to overcome certain obstacles. But in case you want to go to place A to place C, which is at double the distance, you will have to overcome more obstacles. The same thing happens to these electrons. In case I double the length of the conductor, my obstacles will double. So when the obstacles will double, so current will become half. So this is the first important parameter. So it depends upon length of the conductor. More is length of the conductor, more would be the resistance. So R is proportional to L, length. Okay, R is proportional to length of the conductor. Second, area of cross section. You know what is the area of cross section of a wire? So if the area is more, the electron will get more space to pass. So obstacles would be less. Therefore, it is inversely proportional to area of cross section. Like if the road is more width, road has more width, then many vehicles can pass simultaneously. So in this case, when many electrons will pass simultaneously, means resistance is less. Therefore, it is inversely proportional to area. That's what I have written here. R is proportional to 1 upon area. If I combine the two, I will get R is proportional to L upon A. Okay, so I will get R is proportional to L upon A. Now, if I remove this sign of proportionality, I put a constant called specific resistance, rho. This rho name is specific resistance, so I get the formula R is equal to rho L upon A. Now this specific resistance depends on the material of the wire. Resistance depends on length, so that is separately covered. Resistance is inversely proportional to area, that is separately covered. So specific resistance only depends on the material of the wire. So its value is different for different materials. So if rho is less, capital R is less, resistance is less. So specific resistance is more, the resistance is more. So for silver, which is best conductor of electricity, value of rho is minimum, and that value is 1.6 multiplied by 10 raised to minus 8 ohm meter. Now how I got ohm meter as unit of specific resistance? See, rho is equal to RA upon L. Isn't it? From this you get rho equal to RA upon L. R is ohm. This is area is meter square. This is meter. So meter square upon meter will give me meter. So I will get this as ohm meter. R is in ohm. Area is in meter square. L is in meter. Meter square upon meter will give me meter. Therefore, specific resistance unit is ohm meter. Therefore, for silver it is minimum value 1.6 10 raised to minus 8 ohm meter. For copper it is slightly more, and for aluminum it is much more. So this is how, based upon the value of rho, we can say that how good a conductor is. Now insulators, as we have learned, they are bad conductors. So its rho value is 10 raised to 12 to 10 raised to 17. 10 raised to 12 to 10 raised to 17. There are two important semiconductors called germanium and silicon. So specific resistance of germanium is 10 raised to minus 1, and for silicon it is 10 raised to 3 ohm meter. So for silicon it is 10 raised to minus 3 ohm meter, whereas for germanium it is about 10 raised to minus 1 ohm meter. So that is why they are called semiconductors, because their value is neither in the range of 10 raised to minus 8 or nor very high value of 10 raised to 12 to 17 as in case of insulators. So they are semiconductors. Is it all right? So the important formula that we have learned today is R is equal to rho L upon A. Rho is called specific resistance. It depends only on the material of the wire. Is it all right? So then we'll proceed further. Now the value of rho changes with temperature, because when the temperature is increased, then the atoms will vibrate with larger amplitude, with more velocity. So when they hit the electrons, it will change to a larger extent. Therefore specific resistance depends on the temperature, and as R is proportional to rho, because R is equal to rho L upon A. So if rho doubles, R will double. So R is therefore rho and R both change as temperature is increased. But this is only for metals, for pure metals. For semiconductors it decreases. For semiconductors rho decreases. The explanation for this would be in the 12th standard. And for alloys it remains almost same. Manganese constant and nichrome, it remains almost same. So this you should learn. Now, how to define resistivity? What is the resistivity rho? Ra upon L. As I told you, the first unit we got ohm, meter square upon meter. So resistivity rho would be equal to R if A is 1 and L is 1. A is 1 means its area of cross section, this is 1, and its length is also 1. So this is 1, this is 1. So now its area will become 1 and this length is also 1. So this becomes a cube. So this becomes a cube of unit length. Therefore, in case you want to find a rho of any material, you make a cube of that material of unit length. Then the resistance across its opposite faces, resistance across its opposite faces will give you the value of rho. So rho is defined as resistance of a material, resistance of, you can say, cube of same material of unit length, or 1 meter cube of across opposite faces of 1 meter cube. Now copper and aluminium, these wires are used for transmission wire or in cable connecting wires. Alloys, manganese and constant, and they are normally used as resistors. Resistor means resistances of some fixed value which we want. So based upon that we will design the length and area of cross section of this. So they are resistors, so value of the resistance is known. Nichrome is used for heating elements, electric iron, toaster, room heater, wherever we are converting electricity to heat.